Well, hi there. Welcome back to our discussion of the geology of the Caribbean. This is part four. We continue our discussion of the Greater Antilles, this time the island of Hispaniola. Okay, now we have left Cuba and come to the island of Hispaniola. We will talk about its physiography and geology. Please refer to this sketch map that I have presented for you here so that you can understand better what I'm talking about. Now, Hispaniola is the second largest island of the Greater Antilles, and it consists of two countries, the country of Haiti in the west and the Dominican Republic in the east. The island is 400 miles long and 160 miles wide. Several northwest trending or oriented mountain ranges across the island. The main physiographic feature in Hispaniola is the Central Cordillera or Cordillera Central, which reaches heights of over 9,500 feet. The highest elevation is that of Pico Duarte, that has an elevation of 10,164 feet above sea level. That's pretty serious, huh? North of Hispaniola lies a narrow submarine trough that is 12,000 feet in water depth. Uh, the trough deepens to the east into the Brownstone Trough. North of this trough sits the shallow platform of the Bahamas. Uh, South of the island, a narrow shelf area uh, drops into deep water. The southern peninsula of Hispaniola passes into the submarine Beata Ridge that we have already talked about. Hispaniola actually began forming during Cretaceous time through island arc related plutonic activity. Uh, the island is really interpreted as being formed from various small and separate island arcs. Plutonic intrusions, metamorphism, and volcanism began concurrently on the largely submerged landmass. The Cordillera Central has abducted peridotite overlying a metamorphosed schist and mylonitic shear zone. Uh, the the basal metamorphic lithologies in Hispaniola are of Jurassic to Cretaceous age. They are exposed along the Cordillera Central of the Dominican Republic and also along the northern range of Haiti. Interestingly enough, the early orogenic episodes described for Cuba are combined in Hispaniola's basal complex. The time of great thrusting in Cuba was an interval of deposition in Hispaniola. Uh, Compressional uh, structures such as thrust faults and folds constitute the main form of structural deformation on the island. The current physiographic landscape result from a thrusting phase of Miocene to Pliocene age. The key lithologies in Hispaniola can be broken down into the basement complex and then pre-Cenozoic and Cenozoic rocks. Under the so-called basement complex, I should say that the oldest rocks include igneous rocks, uh, such as granite, quartz, diorite, andesite, basalt, and volcanic tuff. Uh, Also, sedimentary rocks, mainly in the form of carbonates, and metamorphic rocks such as schist and serpentine. These rocks, this basement complex, makes up the axis of the Cordillera Central. Greenstone and amphibolite occur on the northern part of the island. Pre-Cenozoic strata consist of argillite in the north and limestone in the south. Other volcanic rocks occur in the Massif du Nord, the northern range of Haiti, which are overlain unconformably by marine and non-marine sedimentary strata, as well as radiolayer and chert. Cretaceous rudistis or rudist reefs unconformably overlie sedimentary lithologies. The Cenozoic strata consist of thick sedimentary rock units of Eocene, Oligocene, and Miocene age. Pliocene strata are found to the south, and Pleistocene rocks in general are pretty scarce on the island. Well, this photograph is an illustration of the beautiful, rugged northern coastline of the country of Haiti around Labadie. Well, this photograph here by Cesar Dunn illustrates the topography in the San Cristobal province in the southern part of the Dominican Republic at the foothills of the Cordillera Central. Well, we have finished part 4, so now we go to part 5, which would be the island of Puerto Rico.